Hello all. So far we have discussed about the computer vision pipeline, which involved 4 steps. The first step what we have done was input data. Second step we have studied was pre-processing. And the third step what we have done was feature extraction. Now it's time to feed these extracted features in a vector form to the classifier so that that classifier will output a class label for that particular image. So in today's session, we'll talk about the fourth step involved in computer vision pipeline, which is called as the classification model, and then we'll move on to the last topic, classifier learning algorithm. So we'll consider the same image what we have done in the previous session, image of a motorcycle. Feature extraction algorithm is applied, and these are the features which are extracted in a vector form, hence you call it as feature vectors. So each feature will be considered by the machine. Based on that feature, the machine will try to find the probability of that given image belongs to any of the 3 labels. In this example, the labels what we are considering is car, motorcycle or a dog. So first let us consider the feature as wheel. Based on this feature, machine will try to predict whether this feature belongs to either of these 3 labels, car, motorcycle and dog. So clearly this feature indicates that it is not a dog, then it could be an image of a car or a motorcycle. So the next, it will take the next feature, it will move on to the next feature. For example, it will take the feature as headlights. Now this headlight clearly shows that it has higher probability that it belongs to motorcycle than a car. That is, the probability of this image belonging to motorcycle is more than the probability of this image belonging to car based on this feature of headlight. The next feature what the machine will consider is mudguards, and it goes on taking one by one feature and tries to find the probability of that image belonging to either dog, car or motorcycle, and this process keep going through all the features like the body shape, pedal and so on until the machine arrives at a best guess of the object in the image. So this is the process how classification model performs classification task to label for the particular image. Next, the next topic is classifier learning algorithm. That is how a classifier learns the features and then predicts the given image belonging to any of the labels of the output. So the classification task is done by 2 ways. The first is traditional machine learning algorithms, which makes use of, for example, support vector machine to classify the given image, but it has few drawbacks. Manually, the features are being extracted by the data scientist in traditional machine learning algorithms. So the next type of classification task can be done by deep neural network algorithms, which makes use of convolutional neural networks, and this CNNs has higher accuracy in classifying compared to that of traditional machine learning algorithms. This is the block diagram where the features are automatically extracted by the machine itself, and then the output is classified depending upon the label provided. The input images will pass through number of layers of neural network to learn their features. So you can see that you have 1, 2, so on till n number of layers in the network. More the number of layers, more depth will be neural network, hence you call it as deep neural network. This deep represents the number of layers in the neural network. The deeper the network, the more it will learn the features of the data set, and hence the name deep learning. So this second layer will try to learn the features extracted from the first. This layer will try to learn the features which are extracted from the previous layer, and this layer tries to learn the features which are extracted from the previous layer. This output layer is called as the classification layer, which will classify the given image as a motorcycle or not a motorcycle based on all the features which are extracted by the previous layers. So you can see here the input image flows through the network layers to learn its features. Early layers detect patterns in the image, then later layers detect patterns within the patterns, and so on until it creates the feature vector. And in the classification layer, it looks at the feature vector extracted by the previous layer, as I told, and fires the upper node if it sees the features of a motorcycle, or lower node if it doesn't. This is the upper node if that feature matches with the motorcycle, and if that feature doesn't match with the motorcycle, then it will fire the lower node, which is not a motorcycle. So we have done with all the first part of first unit. Let us look on to the summary what we have done till now. We have gone through the components of vision system, which has two components, sensing devices and interpreting devices. Next, we talked about the process involved in interpreting image which is captured by a sensing device, which is also called as computer vision pipeline process, which had 4 steps. The first step involved input image, second step involved in pre-processing, third step involved in feature extraction, and the fourth step what we have done just now was classification model. Coming to the third summary, we have talked about the representation of an image. Image can be represented as xy in the form of x and y coordinates, which is nothing but a two-dimensional representation. We also have talked about two types of images, grayscale images and colored images. Grayscale images have one channel and colored images have 3 channels, represented as R, G and B respectively. We have also gone through image processing techniques, which are nothing but standardization of the images, normalization, grayscale conversion, data augmentation and so on. And the last, we have talked about the features which are considered to be as the unique properties to classify the object, and a good feature is used to distinguish objects from one another. At the end, we have talked about the classifier learning algorithm, where we have shown the differences between the learning algorithm used by machine learning as well as neural networks. So this is the end of today's session. Thank you.